Question 11. The first derivative of the function of f is given by f prime of x equals that function. How many points of inflection does the graph of f have on the interval from 0 to 2 pi? So these, now that they're the calculator questions, I'll do my best to take a picture of what the graphing calculator looks like and then put it up here on the screen so you guys can see it. And I'll do my best to describe what I'm doing on the graphing calculator so that you guys can kind of get an idea of how you would do it as well. I understand that not all of you guys have graphing calculators at home, and so you might not be able to do it on that. If you had to use Desmos in order to solve this, that's fine. You can get the same image on Desmos. You just need to be careful because doing it on Desmos, in my opinion, is actually a little bit easier than using a graphing calculator because Desmos just is very good about formatting things, and so it's very easy and it's a very visual program, and a graphing calculator is more of a tool that you need to learn how to work itself before you can actually understand how to do it on there. So, like I said, I'll do my best to describe it to you guys so that you guys can kind of see what I'm seeing, I guess. So, first of all, I graphed this function in y1. So go ahead and if you haven't yet plugged that function into y1, or if you're using Desmos, go ahead and type that function into Desmos. And just make sure you're very careful about how you type it in to make sure you don't make any mistakes. Next, on a graphing calculator, I wanted to make sure that I had a good viewing window so that I could see the entire function from 0 to 2 pi. So here is the window that I used for my graphing calculator. Alright, so I used a window from 0 to 2 pi for x values, and then for y values I just used from negative to 20 to 20. So you guys could use those values as well. And it gives you a nice clean picture of what the graph looks like. It looks something like this. So you can see a nice clean picture of what our graph actually looks like. Now, if I take that picture off, you'll notice that the question is asking how many points of inflection does the graph of f have on the interval? So if I'm looking at the first derivative, and again that little slip of paper that I gave you, if I'm trying to find a point of inflection on the first, or on the original function, on the second derivative I'm looking for horizontal tangents. That's what I'm looking for. I'm sorry, on the first derivative I'm looking for horizontal tangents. So when I graph this function, when I have this, I'm looking for horizontal tangents on this function in order to figure out where my original function has a point of inflection. So a horizontal tangent meaning a turning point. It can't just be any flat part, but it has to be a turning point. So I see 1, oops, that's not a very good one, 2, 3, 4. I see 4 turning points on my graph, which means that on the original function there must be 4 points of inflection on the original function. So to answer this question, the answer would be 4. And again, for the reason that there are 4 turning points on the graph of the derivative. You're going to notice that, by the way, for a lot of these calculator questions, the reason they're calculator questions is because this equation would be way too difficult to talk about by hand, like manipulate by hand, I should say. Because normally in order to find points of inflection for a first derivative, we would go back and take the second derivative and then find where it's equal to 0, but you wouldn't even want to go near taking the derivative of this function. So calculator questions, they'll often do that to you where they put difficult equations in them asking simple concepts. So this is a very simple concept that if you can look at the graph of this function and not even needing to graph it yourself, but just look at the graph of it, it's very simple to tell how many points of inflection it would have based on that. So again, the answer is 4 for the reason that it has 4 turning points on the first derivative.